In this video, we're going to talk about 6.1, which is our introduction to linear transformations. We use a capital T to denote a linear transformation, and it has two properties. T of u plus v is equal to T of u plus T of v, and 2T of cu is equal to C times T of u. If you think that looks foreign and you've never seen that before, I assure you that you've actually seen at least three things in calculus that are linear transformations, and perhaps we'll talk about some of those as we go along. But the limit operator, where the limit of the sum was equal to the sum of the limits. The differential operator, where the derivative of the sum was the sum of the derivatives, and the integral operator, where the integral of the sum was the sum of the integrals, as well as all of those, the constant multiple passed through the operator and came to the front like that, makes all three of those linear transformations. So you have seen these before. You've dealt with them quite a bit actually in calculus. Summation symbols would also be another one, that a sum of two functions like that, you could split up the summation, the constant passes through the summation symbol. So we have lots of examples that we've dealt with from Calculus 1 and Calculus 2. You might be able to think of some others here, but we're going to come up with some specific things that we're going to try to see if they are linear transformations. So let's look at number 1 and finding the image and pre-image of a transformation. So image would be the output value of the transformation. Pre-image would be what input value gives you the output value. So problem number 1 tells us that T of V1, V2, it takes a two-dimensional vector, is equal to V1 plus V2, comma, V1 minus V2. So it outputs a two-dimensional vector. That's good. So this T goes from R2 to R2, right? We want a V here of V equals 3, -4, and W is 3, 19. So I want T of 3, -4 will be 3 minus 4. Sorry, yep, that's right. And then 3 plus 4, that is -1, 7. And then I want T inverse of 3, 19, so that I get the pre-image of this. We have to do that with some systems of equations here. So to do that, I'm going to need that V1 plus V2 is equal to 3, and V1 minus V2 is equal to 19. Let's add these together, and 2V1 is equal to 22, making V1 equal to 11. If V1 is 11, then V2 is equal to -8. So that makes T inverse of 3, 19 equal to 3, -8. Sorry, 11, -8. So there's my V1, there's my V2. Moving on to number 3, we have T of V1, V2, V3 is equal to 2V1 plus V2, 2V2 minus 3V1, V1 minus V3. And V is equal to -4, 5, 1. And W, which is what I want to find the preimage of, is 4, 1, -1. So T of -4, 5, 1 is -8 plus 5, 10 minus -4, -4 minus 1, that's -3, 14, -5. Two times -4 plus 5 is -3. 2 times 5 is 10 minus 3 times plus 12 makes that 22. There we go. And then I want T inverse of 4, 1, -1. So that is 2V1 plus V2 is equal to 4, -3V1 plus 2V2 is equal to 1, and V1 minus V3 is equal to -1. So I would like to use these two here to solve for V1 and V2 first, multiplying the first equation by -2. Have -4V1 minus 2V2 equals -8. -3V1 plus 2V2 is equal to 1. It's -7, -7V1. V1 is equal to 1. If V1 is 1, 2 plus V2 is equal to 4. V2 is equal to 2. And 1 minus V3 is equal to -1. Negative V3 is equal to -2. V3 is equal to 2. So my preimage here should be 1, 2, 2. That was number 3. Moving on to number 5. 5 says T of V1, V2, V3 is equal to 4V2 minus V1 4v1 plus 5v2. V3 is not part of the right-hand side there. So that's going to be important when we do the pre-image. That V3 can be anything we want to, since it's not involved in the calculation. W equals 3, 9. So T of 2, -3, -1 is 4v2, that's a -12, minus v1, that's -2, 4v1, that's 8, plus 5 times -3, that'll be a -15, that's -14, -7. And then we're going to find our pre-image of 3, 9. And to do that, we're going to say that -v1 plus 4v2 is equal to 3, and 4v1 plus 5v2 is equal to 9. And I'm going to multiply the first equation by -4. So I get 21v2 is equal to 21, and v2 is equal to 1. v2 is 1, -v1 plus 4 equals 3, -v1 equals -1, and v1 equals 1. So my pre-image is going to be 1, 1, and then it doesn't matter what v3 is because we couldn't calculate it. It can be anything that we want. It was not included in this right-hand side of the transformation. All right, let's look at number 7. Number 7 says that we want a linear transformation of two-dimensional vector v1, v2. It's got some square roots and stuff in it. It equals to square root of 2 over 2 v1 minus square root of 2 over 2 v2, comma v1 plus v2, comma 2 v1 minus v2. And we have a v of 1, 1. We have a w of -5 root 2, comma -2, comma -16. So t of 1, 1 is equal to root 2 over 2 minus root 2 over 2, 1 plus 1, comma 2 times 1 minus 1 is 0, 2, and then 2 minus 1 is 1. So 0, 2, 1. And I want the pre-image of -5 root 2, -2, -16. So root 2 over 2 v1 minus root 2 over 2 v2 equals -5 root 2. That changes to v1 minus v2 is equal to -10. Once I multiply everything left and right by 2 over root 2. Then we have V1 plus V2 is equal to -2. Adding those together, 2V2 is equal to -12, making V2 equal to -6. And V1 minus 6 is equal to -2. So V1 is 4. 4, and then -6. And then let's just check that with the last piece here, that we should have 2V1 minus V2 is 8 plus 6 is 14. Write this backwards. V1 V1 plus V2 is -2. And here, let's leave this one alone for a second. Come back to that one. Let's go for the easy ones. V1 plus V2 is equal to a -2. 2V1 minus V2 is equal to -16. 3V1 is equal to -18, making V1 equal to -6. -6 plus V2 is equal to -2, making V2 equal to 4. So that's -6, 4, and then plugging those in to the first term here, I have √2 over 2 times -6 minus √2 over 2 times 4, and that needs to be a -3 √2 minus 2 √2 is a -5 √2, which checks out. So my pre-image is -6, 4. That was number 7. I forgot to number that, but there it is. Let's go ahead and look at number 9 next. Number 9 tells us that we have a linear transformation that's from R2 to R2. And T of x, y equals xy squared. This is a potential linear transformation. We're actually testing to see if it is. So we need to see if is T a linear transformation. I already know it's not, because because x plus y squared is not equal to x squared plus y squared for the second part, but let's prove that to you. So let's take T of U1, U2 is equal to U1, U2 squared. T of V1, V2 is equal to V1, V2 squared. T of U1 plus V1, U2 plus V2 will be equal to U1 plus V1, comma, U2 plus V2 quantity squared. If I wanted to add these two together here, T of U1, U2 plus T V1, V2 would be equal to U1 plus V1, comma, U2 squared plus V2 squared. And those are not equal because U2 plus V2 squared is equal to U2 squared plus 2U2 V2 plus V2 squared. So I have this piece and this piece, but I'm missing that piece on my transformation. So no, not a linear transformation. Okay. Let's look at number 13 next. This is number 9. 13 says that we have T from R2 to R3. T of xy equals square root of x, xy square root of y, and let's look at this. I know this is not linear because of square roots. T of u1, u2 is equal to square root of u1, u2, square root of u2. T of v1, v2 is root v1, v2, square root v2. Add these together, tu1, u2 plus t v1, v2 is equal to root u1 plus root v1, comma, u1, u2 plus v1, v2, comma, root u2 plus root v2. I have t of u1 plus v1, comma, u2 plus v2. That gives me root u1 plus v1, comma, u1, u2 plus u1, v2 plus u2, v1 plus u2, v2, comma, root U2 plus V2. And I see that those things don't equal one another. So T of U1, U2 plus T V1, V2 is not equal to T U1 plus V1, U2 plus V2. So not linear. That was 13. Let's go on to 19. 19 is T is from a 3x3 matrix to a 3x3 matrix using the transformation matrix. T of A is equal to 0, 0, 1, 0, 1, 0, 1, 0, 0 times A. And we want to test this to see if what T of A plus B would be. So that would be 0, 0, 1, 0, 1, 0, 1, 0, 0 times A plus B, which would be 0, 0, 1, 0, 1, 0, 1, 0, 0 A plus 0, 0, 1, 0, 1, 0, 1, 0, 0 B, which is T of A plus T of B. We want T of CA is equal to 0, 0, 1, 0, 1, 0, 1, 0, 0 times CA is equal to C, 0, 0, 1, 0, 1, 0, 1, 0, 0 A is equal to C times T of A. So yes, this is a linear transformation. Problem is number 21. P2 to P2. P2 is polynomials of degree 2 or less. This is T of, it's going to take on a second degree polynomial. It's going to be equal to a 0 plus a 1 plus a 2 plus a 1 plus a 2x plus a 2x squared. I want to see if, let's do T of b naught plus b1x plus b2x squared equals b naught plus b1 plus b2 plus b1 plus b2x plus b2x squared. When I add these together, T a naught plus a1x plus a2x squared plus T b naught plus b1 x plus b2 x squared needs to be equal to a naught, a1, a2, b naught, b1, b2, plus a1, a2, b1, b2, x, plus a2 plus b2 x squared. And let's see what t of a naught plus a1x plus a2x squared plus b naught plus b1x plus b2x squared would be. So we're going to have the constant part. A naught, a1, a2, naught, b1, b2, plus, and then we have the linear part, and the quadratic part, so a1 plus a2 plus b1 plus b2x plus, and then that's going to be a2 plus b2x squared, and those are equal to one another. So passes the first part, t of c times a naught plus a1x plus a2x squared equal to t of c a naught plus c a1x plus c a2x squared is equal to c a naught plus c a1 plus c a2 plus c a1 plus c a2x plus c a2 x squared is equal to c times a naught plus a1 plus a2 plus c times a1 plus a2 x plus c a2 x squared is equal to c times a naught plus a1 plus a2 plus a1 plus a2 x a2x squared. So that's going to be c times t of a naught plus a1x plus a2x squared. So yes, that's a linear transformation. On now to number 27. It says that t of 1, 0, 0 is equal to 2, 4, -1. T of 0, 1, 0 is equal to 1, 3, -2. T of 0, 0, 1 is equal to 0, -2, 2. So I want to find t of 2, -4, 1, which is 2 of these, -4 of those, and 1 of those. So we're going to use the constant multiplier rule and say that this is 2 times 2, 4, -1, minus 4 times 1, 3, -2, plus 1 times 0, -2, 2. So that's going to give me 4, 8, -2, plus -4, -12, 8, plus 0, -2, 2. That's 0, -6. Let's go on to number 31. Which says that t of 1, 1, 1 is equal to 2, 0, -1. T of 0, -1, 2 is equal to -3, 2, -1. And t of 1, 0, 1 is equal to 1, 1, 0. So I'm going to use a matrix here to help me solve for my C1, C2, and C3. If I take these three vectors here and augment them with what I want to put in to -1, 1 to see what my constants on these vectors need to be in order to take linear combinations of these vectors to get this. It tells me that when I RREF this, I get 1, 0, 0, 0, 1, 0, 0, 0, 1, -3/2, -1/2, and 7/2. So C1 is equal to -3/2, C2 is equal to -1/2, and C3 is equal to 7/2. So I'm going to take T of 2, -1, 1 is going to be equal to -3/2 times 2, 0, -1. Minus 1/2 times -3, 2, -1 plus 7/2 times 1, 2, 0. That equals 2, 5/2, 2. Let you use your calculator to figure that out, but that's -3 plus 3/2 plus 7/2. That's 10/2 is 5. 5 and a -3 is a +2. 0, -1 is -1. And plus 7. One, 0. 1, 0. So that is 0, -1, and 7/2. So 7/2 minus 1 is 7/2 minus 2/2 is 5/2. And then I have 3/2 plus a half. So that's 2. And 2 plus 0 is 2. That's where that came from. "33 is next. Tells me that I have a linear transformation given by a matrix here, where A is equal to 0, -1, -1, 0. And all I want is how many columns and how many rows. So this is R, and then this is the number of columns, which is 2, R. The number of rows is 2, like that. 37 is 0, 1, -2, 1, -1, 4, 5, 0, and 0, 1, 3, 1. So we're going to make this a R 4 columns to 3 rows. "39 says for this actual problem 33. So I'm going to erase this part to write 39. It says find T of 1, 1, where you know that T of A is equal to T of V is equal to AV, like that. So we have T of 1, 1 equal to 0, -1, -1, 0 times 1, 1. It's going to be 0, that's -1, and then -1, 0. And that gives me a final answer here of 1, 1 for part A. Sorry, -1, -1, -1, -1. So that was A. For B, they ask us to find the pre-image of 1, 1. So T inverse of 1, 1. And to do that, we're going to say that 0, -1, -1, 0 times V1, V2 is equal to 1, 1. So it's going to be a -V2, -V1 equals 1, 1, which means that V2, V1 equals -1, -1. So this is -1, -1 if V1 is -1 and V2 is -1. And then part C asks us to find the pre-image of 0, 0. So T inverse 0, 0 is going to be, we have 0, -1, -1, 0. v1, v2 of 0, 0. It's going to be negative v2, negative v1. Equals 0, 0. Gives me v1 is 0 and v2 is 0. All right, so that was 39. And we're going to look at number 41 next. '41 asks me to go back and look at number 35, which we did not do. So I have to write down the transition matrix for 35, which was A equals 1, 0, 0, 0, 0, negative 1, 0, 0. Zero, zero, 1, 0, and 0, 0, 0, 2, with T of V equal to AV. And we want to A find T of 2, 1, 2, 1. So that's going to be 1, 0, 0, 0, 0, negative 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 2 times 2, 1, 2, 1. It's going to be equal to 2, negative 1, 2, 2. So this is equal to 2, negative 1, 2, 2. B asks for the pre-image of negative 1, negative 1, negative 1, negative 1. Find that with 1, 0, 0, 0, 0, negative 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 2 times v1, v2, v3, v4 equals negative 1, negative 1, negative 1, negative 1. So that tells me that we have v1, negative v2, v3, 2v4 equals negative 1, negative 1, negative 1, negative 1. That's v1 equals negative 1, v2 equals 1, v3 is negative 1, v4 equals negative 1/2, making this pre-image negative 1, 1, negative 1, negative 1/2. Wrap up with number 45. And it says to let T be a linear transformation from R2 to R2 such that T of X, Y equals X cosine theta minus Y sine theta, comma, X sine theta plus Y cosine theta. And first we want to find t of 4 for theta equals to 45 degrees. So that's going to be equal to 4 root 2 over 2 minus 4 root 2 over 2 comma 4 root 2 over 2 plus 4 root 2 over 2. And that's 0. And that's 8 root 2 over 2, which is 0, 4 root 2. Then part B asks us to find t of 4 for theta equals to 30 degrees. So that will be 4 times the cosine of 30 degrees minus 4 times the sine of 30 degrees. And then that's 4 times the sine of 30 degrees plus 4 times the cosine of 30 degrees is 2 root 3 minus 2, and then 2 plus 2 root 3 is the same as 2 root 3 plus 2. And part C asks to find t of 5, 0 when theta equals 120 degrees. So 120 degrees is a 60-degree reference angle. Up here at, it's going to be cosine is -1/2. Sine is root 3 over 2. So this is going to be equal to 5 cosine plus or minus y is 0, comma, and then x is 5, sine is root 3 over 2 plus 0. So that's -5/2, comma 5 root 3 over 2. And that is it for this video. We'll come back next time and talk about 6.2, which is the kernel and range of a linear transformation. So I'll see you for next video.